Let's start by meeting a leading authority on the subject, Dr. Atom. Now, observing the professor himself, we can see that his structure resembles, in many ways, something almost as vast as the atom is small, the solar system. And there are certain similarities. Here is the center with electrons in surrounding orbits. But whereas the planet's movement of electrons is slightly different, there are other differences too. Hey, hold it! Thank you. Now, the solar system together is electrical. The electrons, which are negative, are attracted by the protons, which are positive, and vice versa. But here in the nucleus are other particles with no electrical charge, called neutrons. Very important characters, too, as we shall see. And equally important when it comes to atomic energy is what scientists call the atom's binding force. It's a kind of cosmic glue holding the nucleus together. This, then, is a single atom, but certainly not all atoms are alike.
Democritus was a Greek philosopher in the year 460 BC. He said all things are made of atomos or atoms. In the year 1807, John Dalton created a model of the atom. It was a simple solid sphere with no subatomic particles and no nucleus. His atom was solid throughout, which is incorrect. Dalton was known as the father of modern atomic theory. Dalton's atomic theory was that atoms of a given element are different from those of any other element. He also said that all atoms of a given element are identical. Joseph Thomson created the plum pudding model in 1898. He is credited to discovering the electron. Thomson brought the electrons into Dalton's solid atom. The model was still a solid sphere and had no neutrons. In 1911, the nuclear atom model, or the nucleus, was discovered by Ernest Rutherford. In his gold foil experiment, he revealed the nucleus, protons, and empty space. Rutherford's atom has protons in the nucleus, electrons outside the nucleus, and empty space. In Rutherford's gold foil experiment, he fired radioactive alpha particles at a sheet of gold foil. Most went through, proving that atoms are empty space. 1 in 8,000 were deflected off course or bounced back. Niels Bohr created the solar system, or planetary model, in 1913. He believed everything about Rutherford's model, but expanded Rutherford's electrons. Bohr said that electrons orbit the nucleus in fixed, predictable circles. He also said that electrons can absorb energy and jump up and down between energy levels. Still, there were no neutrons in this model. Erwin Schrödinger created the quantum mechanical model, also known as the electron cloud model. His theory was that electrons moved in waves. He said that electrons are not fixed in circular orbits but orbitals. They spin around the nucleus. In 1932, James Chadwick found the neutron, which was predicted by Rutherford. And in the 1960s, Marie Gell-Mann found that protons and neutrons are made of smaller particles called quarks.